the chat. If someone wants to ask something after the first two presentations, we will give the floor to anyone who would like to make a question or a comment.
Yeah.
So yeah, we're very happy to have everyone here, and we will continue this kind of educational, let's say, webinars inside InnoAgora. And I think we could start maybe with Stelios Mantas. Olina, you can
Yeah.
coordinate if you.
We can start with Mr. Mantas, and he's going to give an overview of the cloud and its capabilities, and then we're going to move on with Mr. Kampakis. It's going to be approximately 10 to 15 minutes each presentation, and then we're going to have a round of Q&A, and like it's going to be like a panel discussion, I would say.
Before
Yeah.
we continue with Stelios, just a quick note, because we do have two Stelioses here, okay, Stelios and Stelios. The first Stelios has been working in banks for the past, I don't know, more than 15 years, and
you make me look old. Say
no, you are old and beautiful. Okay, so
He just finished the university and just decided to.
or he was thinking of working for banks for many years. Okay, he just actually joined, but still, yeah, he is the one who has fiddling around, and I'm using the word fiddling around with a huge data, big data, trying to fit products against consumer behaviors, fiddling again behaviors and data from more than 16 million clients. So this was a tough job. And the other Stelios, who is with no view at the moment, who is in England, he was really experienced in guiding companies on how to deal with the navigation in this big data ocean. So if I put it on the same table in the correct sequence, Stelios number one, please offer us your experience honestly, because I know what means to manipulate, consumer behavior and try to find results.
Thank you, Panagiotis. Thank you, everybody. I'm really glad I'm here today to discuss with all of you. As Panagiotis mentioned, in my previous job, I was responsible for running the analytics, the data analytics for National Bank of Greece, where it was a pretty challenging task, because we started quite a few years back, where the capabilities and the features available by technology were not that many as they are today. But still, we managed to pull through a very huge initiative for the Greek banking sector to set up a true analytics center of excellence. And with this today, I think NBG is, if not leading, is one of the leaders in the area of analytics in Greece. But today, I would like to start our discussion not talking about analytics, but I'm talking about enablers, and that can help in your analytics journey. And I would say that the key enabler at this point that can help you in this path will be cloud. So together with the other Stelios, we will split our presentations in two. So initially, I will speak about cloud and the characteristics of cloud, because I think it's important for everybody that eventually will manage large amounts of data and analyze them. It's important to understand what cloud is, because cloud will be the enabler to move forward. And I think it's also going to be a nice opportunity to reach a common ground, understand the technologies behind it, and the features that are available, and what in the end can be the impact of cloud to a business, either startup or a mature business. So let's say that we start with a presentation of Cloud 101. So I would ask for Morlina to make me a presenter so that I can share a presentation that I have prepared for all of us. And I think it will take a couple of seconds for the feature to activate.
Yeah.
And yes, now I'm a presenter. So let me share my desktop. Okay. Okay, so Cloud 101. Do you speak cloud? So we will start with some cloud computing basic concepts. I urge you, if you have a question that you think it's more relevant to be answered at this point and not later in the QA session, please shoot. And with the help of Olina, we will respond to it immediately. So I'm going to the very basics. I don't know, how experienced each one of you is here. So I will start with the really basics and move it a bit forward. So what we're saying that the traditional technology environment has a data center, it has hardware, servers, it has operating systems and infrastructure software. And on top of that stands the development and integration platforms. And finally, we have the IT applications that will provide value to the business services. So this is a pretty complex environment with multiple layers depending on each other, and which actually have some issues or some challenges. First of all, spending is growing. The IT spending is growing constantly. You will see, for example, in banking, almost 7% of their revenue, not their profit, is spent on IT. It has lack of scalability. Enterprises wants to grow, but the current setup prevents them from growing as fast as they would like to do. In many cases, we have out of service, servers crash, data centers fail, software has bugs, and that affects the impact on time to market. So businesses want to expand fast, and with their current capabilities, then that I can support it. And finally, and I think one of the most important things is the IT talents. As technology evolves, the new professionals are used to new technology, and it's very difficult to them to work with older technology, creating an operational risk for the enterprises. Moving forward, what is cloud? So cloud is a new way of building IT services. So instead of design and build and run components, we follow a consume model where you consume IT resources provided third party. This is called the flexible consumption-based model, and this is the model based on which the cloud works. Just to understand what this means. So back in the early 90s, 900s actually, the big factor is that they wanted energy, electricity to work. Usually they had some kind of generators very close to the factory, working to generate the necessary electricity for the factory to work. But as the network evolved and the electricity network was built, these generators was abandoned for the sake of the actual wires that we see flying over our houses. And started actually a revolution, because no longer these generators were necessary, since the electricity would be able to be transferred through the electricity network. And this is today's electricity network. You will see some blue dots, some red dots, and some orange dots, which actually represent the three major players in the cloud community today: Microsoft with the blue, Amazon with the orange, and GCP, Google Cloud Platform with the red, that are covering the entire globe. And actually, this picture is a few months back. Today, there are far more dots, and actually, we're waiting one of these dots to very soon appear and also increase, as very recently Microsoft announced that there will be the data center also here in Athens. Now, if you want to understand this technology there, as we mentioned it, let's have a house analogy. So we have an experience like having a cup of coffee in my living room, sitting on my couch while being in my house. The analogy will be, we have a business outcome using a software application that sits on an application platform, and this resides within an infrastructure. And if we're gonna move it to the cloud, these are the different cloud options that are available today. So the first case is like buying a house where you have the house, you have the furniture, you are in your living room and you're having your coffee, as we said before. Business outcomes, software applications, application platform, and infrastructure. The first option in cloud is to use a model called IaaS, Infrastructure as a Service, where in that case, what you are actually doing is you are renting on a consumption-based model the infrastructure, the servers. All the rest are your responsibility. The second, actually, this type of model is very common when a company, without having to do major work in their applications, in their capabilities, wants to move quickly to the cloud, and it helps when you want to expand your data, your infrastructure, and you don't want to buy new hardware. The second option is platform as a service, PaaS, where in this case you have like owning the house and owning the furniture. And this is the case where, for example, you can receive services like databases or operating systems as a service. So the service provider, the cloud service provider, would be responsible to give you both the infrastructure, both the servers, and some systemic software like databases where your applications will stay. The next, and pretty common, especially in new companies and startups where they're building software as a service, is you provide a specific service, and this is available to the end user. A very common example, it's like, for example, Gmail, which is a software as a service, or maybe if you want to use Salesforce, which is a CRM, which again is a software as a service. In that case, you just log in, you put a credit card or an account, and you start using the service immediately. And the final model is the business process as a service, which in my belief, it's something that will dominate in the future. It's actually linking, like a chain, different software as a services to have a full experience. For example, if you have an e-shop and you would like to sell something, by using a model as a business process as a service, it means that under the same umbrella, you will have the application that is making a post on Instagram, collecting responses, running the shop, does the actual payment processing, generates reports, contacts maybe your courier service, and also sends notifications to the client. So it's an end-to-end business process. Now, if you decide to go with a cloud, there is the option to have a private cloud. It means to have in a data center a cloud-like experience without this infrastructure be shared by others. So it's totally yours and totally private without accessing the internet. Public cloud, which is what we can easily get for AWS or Azure, and which is a public cloud, and there you can create by yourself new servers and new services, and hybrid, which is the combination of the two. And the characteristics of the cloud platforms is, as we said, it's a consumption-based model, so pay per use. As long as you use it, you pay for it. It's self-service, so you don't need somebody to create for you a server or whatever. This is something that you can do it yourself. It's scalable. If you need additional capacity, additional CPU or RAM or network, you can do it very easily. Highly available. The cloud service providers had made sure that their systems are always up and there are no problems of systems offline or whatever. Best of breed technologies, the cloud service providers are introducing new features all the time. So, for example, machine learning, AI, or data that Stelios will describe us in a few minutes, in their newest form are present in the cloud, and of course integrations, because it helps people to build the connections that enables integration between different platforms. Now, moving on to business and how cloud is impacting business. First of all, as we said, for the application hosting infrastructure is cheaper and faster. It can help build products faster, and that helps the enterprise introduce new products very quickly. It has innovative services and accelerators so that using, as we said, functionality like machine learning, we can differentiate ourselves from competition. New business and service models. I remind you the case of Netflix, we will mention it later on, that until they joined the cloud revolution, they were just a company selling and renting DVDs over normal mail. And the ecosystems, meaning that enables companies to work with them and build alliances that in the end can help to expand the business. And what will be for the business? So first of all, it's technology resilience and disaster recovery, meaning security. Move beyond limitations, so you don't have the limitations that the legacy platform currently support. And that will help you to build new functionality very fast. And of course, by using new services, as we said, you can build a new business and reduce cost to income and improve time to market. Some numbers. 90% of the enterprises already use cloud, and we expect that by the end of this year, 83% of all enterprise workloads will be in the cloud. But one of the more important things is that in this year, almost 500 billion will spend on cloud services. So there is a very, very heavy investment from all sides. The banks already are using the cloud in a great extent, followed by technology, retail, even the public sector has started joining the cloud, followed by energy and industrial. And based on the analyst, more than 50% of the IT spending by 2025, so in 3 years, will be over in cloud. And there is an annual growth rate of almost 14% that will continue until 2025. And we also expect that 80% of the organizations are expected to migrate to the cloud services by 2025. And this is a case, as we mentioned, for Netflix. So, as we said, in 2000, Netflix was just selling DVDs, renting DVDs through a mailing service, running only in US. Competition back then was Blockbuster, with almost 5,000 shops worldwide and 8 billion in revenues. But slowly Netflix starts streaming using AWS, and eventually we reach today where a Blockbuster is closed, and Netflix has reached 220 million subscribers worldwide. It's a totally new business, and of course, new companies are following with Apple TV and Prime Video and Disney Plus and Hulu. Now, main uses of cloud across industries, financial services, a lot in fraud detection, and virus fintech solutions mainly focused on payments. Retail and consumer for e-commerce platforms and customer behaviors and voice-assisted interactions. Tech and telecommunications, AI call centers, and new digital services, public sector infrastructure, and the public service digitalization. And for energy and industrial, there is a very heavy use for IoT that will help in predictive maintenance and forecasts. And if we go to specific use cases for fraud detection, investment and advisory, we have also here the case of Capital One that help us reduce significantly the footprint of the data center. Bank of America, which is using blockchain for trade finance. Deutsche Bank for Workday human capital solutions, and DBS for cloud environment that will help us a lot to support over customer traffic. And with this introduction, I pass it over to Stelios to give us his insights on the data using cloud. So, Stelios, the floor is on you.
Thank you a lot, Mr. Mantas. Mr. Kampakis, you can take over.
Perfect. Thanks, everyone. Okay, give me a second to share my screen, desktop window. Okay. Can you all see my PowerPoint?
Yeah.
Okay, perfect. So thanks everyone for making it here, and thank you for organizing this. Like a very quick 2-second intro about who I am. Like Olina said, I identify with the title of a data scientist. I have more than 10 years of experience in this area. These days, 70% of my work is in data science, and about 30% is in blockchain. I'm an honorary research fellow of UCL's Blockchain Center. That's where I also got my PhD. But I'm also a data science advisor for London Business School, for Cambridge University's Business School, and I've also written up a book on data science called The Decision Maker's Handbook to Data Science. If you want to learn more about myself, feel free to visit those links, the Tesseract.academy, and my personal webpage at thedatascientist.com. So, what I'll attempt to do over the next 10 to 15 minutes, I'll attempt to do the very difficult task of breaking data science down in a very simple and easy to understand way for someone who is non-technical, right? My assumption is that you're interested in data science, but you have no intention of becoming data scientists yourself. So I'll give a very high-level overview of what data science is, some terms, some of the jargon. I'll try to demystify it, and I'll finish off the presentation with a few words about what it means for an organization to be data-driven and how an organization can take the steps towards becoming data-driven and why this is important. So before we get there, I always like to start these presentations with a question. Okay? I like to ask, what is data science? And the reason is that this is one of the, let's say data science is a term that's often been used and abused, much like artificial intelligence, machine learning. And in reality, data science is more of an umbrella term, which simply means try to use data to do useful stuff. There's a very long history of humans trying to use data for all sorts of purposes. And in reality, data science is a field that has about a history of about 200 years. So that's one of my favorite graphs, which seems a bit intimidating, but it's really simple once you get down to it. Where at the center you can see data science sits at the core as an overarching theme, and then around it you have all these circles, and each circle represents a discipline. And you can see how many of the terms that you might have encountered over the years, how they relate to each other. For example, machine learning, something which many people don't know, is a subfield of AI, and they're related to statistics, and there's also a relationship with data mining. And essentially, data science came about as a term because before this term was created, all these disciplines dealing with data analysis, they were fragmented. They were in different places, maybe in different institutions, different geographies, used their own terminology. And data science actually managed to bring this together. This was a development that took place around the turn of the millennium, when a combination of factors, including the cloud, which Stelios spoke about earlier, but also the internet, led to an explosion of data. Suddenly, all these disciplines became way more important than they were, in the 80s or the 90s. Something else that's very important to mention on this figure is that while data science is at the core, around data science you have these arrows, which represent what I like to refer to as the soft parts of data science. Things like business strategy, domain knowledge, presentation, problem solving. I think these are integral components of data science, largely because data science is an applied discipline. Right? So sometimes AI, machine learning, these fields can seem somewhat theoretical, and they might actually be. But I'd like to state that data science, to a large extent, is an applied field, and its goal is to bring impact to the organization. So in terms of, of an overview, if you could, let's say, briefly, let's try to simplify the previous graph, I'd say that there are three core fields, in data science, artificial intelligence, machine learning, and statistics. Historically, statistics came first, then AI, and then machine learning. And then there are many other subfields which have a smaller audience, like deep learning, pattern recognition, computational intelligence, which you might occasionally encounter. In actuality, these days, when you hear about data science or data scientists, this usually refers to machine learning practitioners, with very few companies actually really doing AI in the traditional sense of the term. Also, and this will also briefly mention hiring. This kind of breakdown is actually very important for organizations that are looking to build teams of data scientists, build their team internally, because depending on the background of a data scientist, whether they have, for example, more training in statistical modeling or machine learning, the expectations as to what they can or can't do can be slightly different. But in general, data science has like encapsulated all these different themes into one. I think it's worth mentioning, like, a small note around artificial intelligence, which is this now seems to be the dominant term that's being used in place of AI. You see this a lot in startups, scale-ups. We're using AI for this, we're using AI for that. I think this is the loose definition of AI, as in the original vision behind AI, as it was said at least during the 50s, was to create autonomous machines. So I'd like to think that applications like autonomous vehicles are real artificial intelligence. But in the reality, most companies that are claiming they're doing AI, they're just using glorified machine learning or statistics quite often. But they use AI because it sounds cooler, helps them raise money, etc., etc. Moving on to applications, as a decision maker, whether you're a startup founder, whether you're a mid-level manager in a big organization, one of the things that's important to understand is how data science is being used. And I think now we're in a stage of the maturity curve where data science has already been adopted by many industries, and we hear like about case studies and new use cases all the time. And sometimes this can be intimidating because each one of those use cases or each one of those case studies might sound like they might sound as if they're like a bit special. So sometimes decision makers make the mistake of thinking that because, for example, a particular application is used in a sector, let's say banking or finance or shipping, then this application exists only in this sector. And that's not true, because if you take all these use cases and you group them together, then you'll quickly realize that usually there are three major families of applications which probably cover 90% of the stuff out there. Okay, so in most cases, deal either with what we call descriptive data science, descriptive analytics, which is the most vanilla and simplest version of applied data science. That is dashboards, graphs, the kind of things that most businesses now are familiar with. And then we see some sectors and some businesses moving towards predictive machine learning as well as prescriptive. So prediction is, I think, where machine learning and data science can provide the best value. So whether we're talking about automation or whether we're talking about making forecasts about things that might happen in the future, and then prescriptive data science, prescriptive machine learning refers to full-blown automation. Okay. So in general, when you think about use cases, it's good to try and think about these three families. And one note, like towards the last few slides, we'll also come back to, again, to a different way to look into the families of use cases. And we'll briefly mention the differences between being data-informed and data-driven. So please keep this breakdown in mind. And again, it might look as if I'm going over the slides too quick. I know we don't have too much time, so I just hope I'm going to give you a taste there. And then during the Q&A, happy to expand upon any of those points you find most interesting and covered in more depth. Another topic, data science, and one of the things that decision makers should know when dealing with data science is data management. Okay, so data management is like, again, an overarching theme. When you break it down, it includes many other components: data architecture, databases, data governance. There are many, many different aspects to it, as well as data quality. That's one of the areas that I've actually spent a considerable amount of time on. And unfortunately, data quality in most industries is still not that great, primarily due to the lack of data standards. And again, this is a very long conversation around data architecture, data quality. Now, there are some other concerns like GDPR, AI ethics seems to be becoming another new concern, since we expect to see some regulation around AI ethics, which will impact data storage requirements over the next few years. But in general, the best recommendation I can give to anyone regarding data management is to follow a data strategy from day zero, which sounds something like very simple, but in reality, most businesses do not do it. And data strategy refers to having an overarching vision of where you want the business to be data-wise and in the long run. Okay, most businesses are not so much focused on data strategy. Rather, unfortunately, they're focused on data tactics. So they tend to work somewhat erratically, primarily because I think data science, while it's being used in many organizations, it's still relatively a new concept for many of those organizations. Hence, they tend to think about data problems in an ad hoc basis. Um, Here we can skip this. And now let's move on to doing data science. Okay, so let's assume that you have a good understanding of data science, you know about some of the problems that you want to solve using data science, and you also have some data strategy in place. Okay, so obviously doing data science within an organization doesn't have to be complicated as long as some steps are being followed. Quite often, as you can see on this very funny picture here, misunderstandings happen. Right? So, for example, sometimes managers might have very high expectations about data science. That's the same true for customers. But in reality, data science requires the integration of many different parts in order to deliver value to the organization. And if I could really give one tip to anyone who's listening to this presentation around how you can use data science in your company the right way, the best advice I could give you is that, first of all, you have to realize that there are essentially at least two actors in what I call the data science process. Okay, and that's the domain expert and the data scientist. So let's assume that you have some data you want to analyze, you have some use cases in mind, and you've hired someone or you're building an internal team. Something very important to understand is that there are certain steps that have to be followed in order to get from defining the problem all the way to generating value for the business. And for better or for worse, this is something that's difficult to outsource 100% to a data scientist. And this often requires a domain expert, which that's again a very big conversation where this is the person who really understands the business of the sector, which in some cases, if we're talking about startups, this can be the CEO. In bigger organizations, this can be a CIO, a CTO, or it can be a manager of a certain function, again, depending on the size of the organization. And again, this sounds like very simple. In practice, one of the most common mistakes I've seen happening is organizations building internal teams without really being aware of this interplay. So this is where some frameworks like CrispDM, I understand there's lots of information on this slide. I'm just going to briefly say a few words, and if you think that's interesting, we can just expand upon this during the Q&A. That's a data science framework created by IBM. They also have produced a version 2 of that framework. If you ask my opinion, I think version 1 is the best. And essentially what this framework is demonstrating here is that there are certain steps involved in delivering value to an organization and makes aware both the data scientist, but also the decision maker, the stakeholders of all these individual steps. So whereas many decision makers think that a data scientist can go through the full process, actually viewing the business as a machine and understanding the drivers is something that usually happens from the on the part of the stakeholder. There's something else which often missed is the financial impact. Okay, so this is something which is not always understandable by data science teams. And frameworks like that can really help structure projects, can help structure the process in which data science teams work and operate. So that was about data science processes. Now, data informed versus data driven. I mentioned in the beginning that most of the use cases for data science, they break down into certain families, okay? And another way to see this is on the cultural layer. The reason I have Brad Pitt on this slide is not because I'm a fan of Brad Pitt, but because of the movie Moneyball, okay? So that's a very interesting film. On the surface, it might look as if it is a film about baseball, about sports. In reality, it's the only film in the world that really talks about data culture. Okay, if you've not seen it and you're interested in this topic, it's actually an enjoyable film. At least that's what I believe about it. It's definitely worth watching. And it's very important to understand what are the differences between data informed and data driven, because this is something which can drive the data strategy of an organization and the vision they have for how to build competencies based on data. So most organizations right now, the data informed, which means they collect data, they're using it in some way, use it in a simple way like dashboards or Excel. This goes back to descriptive analytics, but many other organizations which are more ambitious, they want to go towards data-driven decision making. So this is when they're using predictive analytics or prescriptive analytics. Okay, and some organizations like Amazon, which is primarily a data company, not a retailer, they're trying to automate end-to-end all operations. And this is where most organizations stand, and this is where some organizations want to go. But obviously, some organizations like mistake these two visions, and quite often they underestimate the difficulty of most companies will actually work towards that vision. And a few more words about how to start for those of you who want to take this journey to become data-driven. Usually there are two approaches, as I call them, the baby steps approach and the use case approach. Probably we don't have enough time to expand upon this, but this is what I've seen in practice. The baby steps approach refers to the approach of that some organizations for which data is not a priority, they just make some small steps here and there, like collecting data and maybe doing some analysis here and there until they feel that they're mature enough that they can actually pursue a project, a bigger project, and invest some resources. The use case approach is a bit better, but it happens less often in practice. So these are some organizations that follow this approach. They have a better vision, more clarity around how to achieve. And in the process of achieving this vision, starting usually with one project, then and they also help transform the rest of the business. I'm going to skip the hiring slide. And then some conclusions. I hope we're pretty much on time. Becoming data-driven is obviously the ultimate ambition for any organization that is handling data, but there are certain steps that need to be taken until you get there. Okay, so first you have to become data aware, then data proficient, data savvy, and finally data driven. And that's the final slide. These are the 5 things that organizations need to do that want to become data driven, and really data science permeates the organization. So it's not something that can simply be outsourced to 1 or 2 people. It's more of a set of mind. Okay, and again, these lessons, they hold whether you are a sole entrepreneur seeking to raise your seed investment or whether you're a corporation with 30,000 employees. These lessons do not change. Okay, that you need to have the right strategy, you need to have the right people. Technology resides in an integrated, connected architecture, the right processes, which this largely depends on the culture of an organization, and obviously the data and data management. So thanks, everyone. Apologies for trying to cram too much content in a few slides. But again, I hope that this has given you some inspiration. If you want us to elaborate on any point, more than happy to do so. Thank you.
Great. Thank you, Mr. Kampakis. And now we have some more time for questions that you can either share with us through the chat, or you can raise your hand, because I think most of the participants are muted. So you can just raise your hand as a reaction, and then I can give you access to the mic. Or if there is any,
or note down on the chat, if someone wants to.
or otherwise, both our speakers, if they want to add something or if they want to complete the presentation of the other speaker, of course, you can just jump in.
Or they can fire chat between them. Between the two Stelios to Stelios.
One thing I wanted to add is that regarding the cloud and the use of cloud for data analytics projects, is that all cloud providers at this point, they are offering some programs for startups and new companies that can support with consumptions and stuff like that. So if you are interested, through Olina, I can share some contact details and some programs that some of you might find useful, in your first steps in the cloud environment.
Perfect. And of course, if our speakers agree, we could also share their presentations or some of the information that they have shared with us today, so you can have like a debriefing of the webinar. Do we have any questions or?
I have to make a small addition to what we heard, perhaps, because everything that the experience of the two Stelioses is gathering ourselves to a point that we have to understand, evaluate, and appreciate the terminology of using the word manipulation behind the data. The cloud offered and the technique by two Stelioses, they're using the ground that we can have the data to work in favor of us in order to stress different scenarios of hypothesis testing in different parameters of any sectors of the economy. For example, we have seen scientists trying to test and manipulate, that means use in a clever way, the data analytics and the cloud capabilities between biodata metrics, biohealth indicators, analyzing something like multi-billions of RNA, DNA sequences in a second or in a minute, okay, trying to stress scenarios and prove that the product already supported by a company, an agency or a pharmaceutical does the job or doesn't do the job, okay? So cloud capabilities and any other techniques use a perfect ground for hypothesis testing, proving, and generally, deriving a certain result of a proof of concept in the worst case scenario, or a failure in proving the proof of concept in the worst case scenario of many companies who try to attempt any kind of project in any sector. So, hypothesis testing is a big deal for us, especially in the financial sector. And of course, Stelios have seen it work in another sector of the economy. Okay.
Great, thank you, Mr. Papageorgiou. And we have a question from Mr. Kotogiannis. If you want to unmute yourself, then you can pose the question if you want. Just so you know, you're muted in case you're trying to talk to us. Oh. So here other posted the question, and the question is concerning data clouding. What about backup in case of network interruption? Is in the very example of electricity, we can have generators? Mr. Mantas, you're also muted.
I'm sorry. Instead, concerning data clouding, what about backup in case of network interruptions? Okay, so actually here, I suppose when we say network interruptions, we mean that there is some unavailability from the cloud service provider that currently supports us. Because if we're talking about network interruptions in general, anyhow you cannot, whenever you have the service, to be able to reach it. Now, today, all of the cloud service providers have multiple data centers and multiple backup lines and secondary lines, and also they can support even within a region multiple data centers or cross region. So they give you the option to work in different regions to ensure that if, for example, something happens with Japan, you also have a data center in Frankfurt, and this does not affect you. But in the case, as you say, that you want to keep your data on-prem, usually on-premise, what we can do is have your disaster site on-prem, and which synchronizes with the cloud service, and you can switch it on at the time of difficulty. Although, to be honest, usually it works the other way around. I mean, you might start by having the on-prem systems as a primary site and the cloud as a disaster. As an overall comment, I would say that it's most probable that you will have a problem on-prem than on cloud. So that's why they have SLAs of several nines that, a small enterprise with an infrastructure, I don't think it can support it. I hope, yeah.
Great. Thank you, Mr. Mantas. So do we have any more questions, any more comments or concerns? Mr. Kodoyan said thank you. So I think if we don't have any more questions, I would personally like to thank our two speakers a lot. It was great having you with us today. Your experience and your presentations were great. So I hope that it added a lot of value to our attendees. Mr. Kalogerakis, would you like to say something? Or
Yeah, maybe we can share them if you allow us. Otherwise, yeah, I guess if someone wants to follow up, we can connect you. And yeah.
For sure, and I think I speak for both Stelioses. You can find us on LinkedIn, link with us, send us a message. We're happy to support.
Yeah,
Great.
yeah. Thank you for this. We are a community that keeps getting bigger, and we like to support each other. So thank you all for attending, and we'll see you in the next webinar, next
yes, on the
online webinar.
29th of March, we have the webinar regarding patents.
We'll talk about patents.
And I think it's going to be very interesting. So we're going to send out invitations, and we're going to make a post on InnoAgora. So just stay tuned, and a lot more is going to follow. Thank you so much, everyone, for attending.
Thank you.
Thank you,
Thank you for
Kostas,
organizing it.
Stelios and Stelios.
Thank you. Bye-bye.
Thank you,
Very
guys.
much.
Bye.
Bye bye.